Okay, I'm going to say this is going to be one of the more important lessons right now, and that's solving quadratic equations. So, first of all, a quadratic is just a second, I have a staple. A quadratic equation is just an equation that can be written in this form that has an x squared. All equations that have x squared as the highest exponent is quadratic. So anytime you have a linear equation, it has one solution. A quadratic could have two, one, or zero. So for example, um, this is an equation that you have both a plus or minus two. If it's a quantity squared, technically you have two, you just have two of the same thing. But we don't need to write x equals 2 twice because two is just your answer. Then for this one, if we square root both sides, we have zero real answers. So, ways that we can solve. We can factor it and then use the null factor law, which was previous. Complete the square, the formula, technology, and really the letter B was the square roots, A and B. Using square roots, I would also include. All right. Factoring is going to be super important. And I know not everybody's good at factoring, and hopefully we'll get better. Whenever you factor, you need to set one side equal to zero, completely factor the other side, use your factor law, and solve. All right, so when you're factoring, notice first of all, this one is equal to zero. Your first rule of factoring, look for a GCF. If there's a GCF, this is the easiest way to factor. So what do each of these have in common? X. So I'm going to factor the x out. We're dividing each by an x. So I'm left with 3x plus 5. Now this looks like section C. Just split it apart. X equals 0. 3x plus 5 equals 0. And solve for x. Minus 5. Divide by 3. And these are my two answers. 0 and negative 5/3. In letter B, it's not equal to 0. I will always move it to the side that makes x squared positive. So I'm going to minus the 5x to bring it to the other side. I'm going to minus the 6 to bring it to the left side. So my equation now equals 0. There is not a GCF with all three, so I'm going to go to 2 parentheses, break x squared into x and x. Then I always say think backwards. Factors of 6 that subtract to get 5. So our two factors of 6 are 1 and 6, 2 and 3. Because the 6 is negative, I need to subtract the two factors to get 5. So I'm going to use 6 and 1. Now, if the 5 is negative, that means the 6 needs to be minus, the 1 needs to be positive. Now I'm going to split it apart, set each one equal to 0. So x equals 6. Set each one equal to 0. X equals negative 1. Those are my two solutions. All right, this one's going to be tougher because there's a leading coefficient with x squared. That always makes it a little bit tougher. We still need to get them equal to 0. So I'm going to subtract the 4x. You always want it to go in descending order. X squared, x constant. There is no GCF with all three terms, so I'm just going to break it apart. Now, to get 4x squared, we can either use 4x and 1x or 2x and 2x. But I'm going to be adding my factors to get 4. So I need 2x and 2x, 1 and 1. Now, the 1 is positive, which means my signs are the same, but the 4 is negative, which means they're both negative. So if you think this is negative 2x to get my negative 4x. Split it apart. 2x minus 1 equals 0. Add 1. Divide by 2. Oops. 1/2. Sorry. And notice this factor is exactly the same as this one. So that's I call that a double root when you have two of the same thing. So x equals 1/2 is the only solution. All right, so I need to move everything over to make it equal 0. I'm moving everything over to be with this 6x squared. So both the 11x and the 10 change sign to move to the other side. All right, so if you don't automatically see what works, in order to get 11, first of all, the 6x squared is made from the front two. The front term has the front two factors. The last term uses the last two factors. So that means that to make 6x squared, we can try 3x and 2x. And then we're going to make 10. So I'm going to use 2 and 5. I'm just going to place them incorrectly at first so you can see what I'm doing. So first I put the 5 and the 2 here. This, when I multiply, makes 10x. This makes 6x. This says I'm going to subtract to get 11. 10 and 6 do not subtract. So then I go back. I'm going to switch the 5 and the 2. This gives me 4x. This gives me 15x. 4 and 15 do subtract to get 11. To get a negative 11, I need a negative 15, so I put the minus here, and a positive 4 to get my negative 11. So factoring is going to be important. That's why we spent so much time doing that last year. All right, I'm just going to erase this now because we're going to split it apart. We have two different factors. 3x plus 2 equals 0. Subtract 2. Divide by 3. There's our first solution. Then I set 2x minus 5 equal to 0. Solve for x, and there's my second solution. Notice whenever I have a leading coefficient, I have fractional answers. I'm going to put that back into your brain for a little bit. All right. We're just going to keep going. All right. So we can never just leave the x in the denominator. So when I solve, first of all, I see that x cannot be 0 because there is an x in the denominator. So I'm just going to kind of state that on the side. But I want to get the x out of the denominator, so I'm going to distribute the x all the way through. When you distribute the x to the second portion, the x goes away, and we're left with this equation. Now I'm going to move the 7x over, and this looks like my regular quadratic equation. Now I'm going to factor. To make 3x squared is just 3x and x. To get 2, I need 2 and 1. Notice 3x is 6x plus 1x is 7 plus plus. Set each factor equal to 0. 3x plus 1 equals 0. Subtract 1. Divide by 3. There's my first solution. Set my second factor equal to 0. Solve for x. There's my second solution. Okay. Next, we're moving on to completing the square. I'm not going to have you write this. Our goal is to get it into this format, and I'm just going to guide you through that, okay? All right, when we complete the square, this is the one time you don't want the equation to equal to 0. What we're going to do is we're going to keep the x's on the same side, and I want you to create a blank. We're going to move the 1 over so it becomes negative, and whatever I do to one side, I'm going to do to the other. Completing the square means I'm going to put a number in here that creates a quantity squared. There is only one number I can put here that completes this square. First of all, this x has to have a coefficient of 1 for this to work. So I'm just going to bring this x down here. I'm going to take half of this number, and then I take this number here squared. That is the number that completes the square. Now let's think about this. X squared plus 4x plus 4. If we factor this, x and x plus 2, because that makes 4, both in the middle and the edge. This is our quantity squared when you're multiplying the same thing times each other. Then I'm going to combine my right side. Negative 1 plus 4 is 3. Now think about how we solved this earlier. If I have just a single x, I can now square root both sides, plus or minus radical 3, subtract 2, and I have my final answer. Completing the square is always kind of a slick method if x squared has a coefficient of 1 and this is an even number. All right, so let's look at example 10. What's the first thing you notice? X squared does not have a coefficient of 1. So the first thing we have to do is divide everything by negative 3. Okay. Then we're going to move our constant over, leaving my room to complete the square. Take half of the middle, and 2 squared plus 4 to both sides. Now this is 4 over 1, but I need to add fractions, so that means I need to get a common denominator. I'm going to multiply top and bottom by 3. 12 thirds is 4. That makes 17 thirds. Square root both sides. X minus 2 equals plus or minus the square root of 17 thirds. Add 2 to both sides. Kind of ugly, but it's doable. All right, so the quadratic formula. I'm always sad when you're not here with me for the quadratic formula because I like to sing. This gives you a whole great big historical note on who's all figured out the quadratic formula. But I like to sing it. La, 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 la. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. And the quadratic formula comes from a general equation that we complete the square with. So let me show you the proof. So first what you do is get rid of your leading coefficient of a, divide everything by a. Move over the constant. we take half of the middle term. When you take half of a fraction, you just double the denominator. Squared, if I take b over 2a squared, I get b squared over 4a squared. Add that to both sides. I'm going to rearrange this. I'd rather have this be b squared minus c over a. Then we're going to square root both sides. Now, I'm going to get a common denominator. First of all, I'm going to put my plus or minus. And I need to get multiply this by 4a, so I have a common denominator. B squared minus 4ac all over 4a squared. Then I'm going to move this over. Opposite of b over 2a, plus or minus. Now, I can't take the square root of the numerator, but I can take the square root of the denominator. Notice that the denominators are the same. And here we go. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. Is there a common denominator? We can put it all together. This is the proof of the quadratic formula. So let's apply it. First of all, you need to have it in descending order. Then a is your leading coefficient of x squared. B is your linear coefficient of -2. C is -6, your constant. Then it's literally just plugging it in. Opposite of b plus or minus square root of b squared minus 4ac all over 2a. Now, a couple of things. Automatically just do the opposite here. B squared, do in your head. -2 squared is 4. 2 times 1 is just 2. Now, a couple of places for mistakes. First of all, if I'm subtracting and this is a negative, that's going to cancel. That'll just be a plus now. So it's 4 plus. Always multiply this first. 4 times 1 times 6, 24. Combine like terms. Now, here's where you have to break down your radical. The square root of 28 is square root of 4 times 7, square root of 7. So it's 2 plus or minus 2 radical 7 all over 2. Do you see how you could write this as 2 over 2 plus or minus 2 radical 7 over 2, because your final answer is 1 plus or minus square root of 7. I will tell you that completing the square with this quadratic would have been way, way easier from the beginning. Remember when I said leading coefficient of 1, even? We'd have gotten this step in like 3 steps rather than all of this. But you need to have both methods kind of handy. Because simplifying the radical is probably where people get stuck. So be careful about that. All right, letter B. A is 2, B is 3, C is -6. X equals opposite of B plus or minus square root of b squared minus 4ac all over 2a. So I just multiplied 2 times a in my head. All right, once again, this is going to make this a plus. Always multiply these 3 numbers first. So the more complicated the answer, this is actually the easiest way, because we end up with the square root of 57. And if you can't simplify the radical, you are done. So actually, the more complicated the problem, the quadratic formula is the way to go. Now, because of the radical determines a whole bunch of stuff. So it gives the number under the radical its own name. The number under the radical, b squared minus 4ac, is called the discriminant. Now, I do not like that they give the discriminant the symbol of the triangle, because to me that means change. But what this is saying, if the number under the radical is greater than 0, positive, there are two distinct real roots. If the number under the radical equals 0, there's only one solution. They call it a repeated root. I also call it a double root. And if the number under the square root is negative, less than 0, there are no real roots. So this just kind of summarizes your final answers. But sometimes it just wants you to tell you about the answer. All right, so to find the discriminant, and this is in your formula booklet, this formula, b squared minus 4ac. So b squared is negative 2 squared is 4, minus 4ac. 4 minus 24 is negative 20. Because this is negative, if I put that under the radical, there are no real roots. So the nature of the roots are just what kind of answers will you have. If the discriminant is negative, there's no real roots. All right. Find the discriminant, b squared minus 4ac. This is going to be plus when I subtract the negative, 12, 24. Because it's a positive value, there are two real roots. Basically, no real roots if this is negative, two real roots if this is positive, and one real root if it's 0. All right, hang on. The bell is going to ring, so I'm going to stop this and I'll finish that last one in just a minute.